Question number 10.2. In the diagram, EBF is a tangent to the larger circle. We can see that if they talk about the tangent, then you have to see tan chord theorem. Okay, you have to see tan chord theorem. Tangent and chord, we can see that one, but we are applying tan chord theorem where in the larger circle, isn't it? Okay, then CDF and ABC are the straight lines with the E and A on the smaller circle AEDB. Okay, so AEDB is a cyclic quadrilateral, isn't it? We can see a cyclic quadrilateral on the smaller circle. Clear. So what is the first question? You have to show that EA and EB, they are equal. EA and EB. Did you see the line EA? That is this line EA and EB, they are equal. So when it comes to question like this, two sides are equal. First you have to think, is it part of a triangle? It's very clear that the triangle ABE contains those two sides, isn't it? Okay, then things are very easy. Somehow, if we can prove that these two angles are equal on the triangle, two angles are equal, we can say that is an isosceles triangle. So sides opposite those equal angles are also equal. Those are the required sides which we have to show that they are equal, isn't it? So that's how we need to do, especially when it comes to two sides. You have to show that they are equal. So you have to check that is it part of a triangle. Here it is like that. EA and EB are they are part of the triangle ABCE, isn't it? Okay, so now I have to show that B1 is equal to A with the valid reason. Okay, yeah. So I have to start from one of the angles. Let me start from B1. Okay, okay. So B1, how do I connect B1 to some other angles? At the end, I have to get what? Angle A. So guys, we can think about that. So it is very clear B1 is equal to B4. Did you see that? B1 is equal to B4. So we are doing 10.2.1. B1, angle B1 is equal to angle B4. All of you know the reason. What is the reason? Vertically opposite, isn't it? Vertically opposite angles. Okay, vertically opposite angles. Okay, now I'm here, B4. Isn't it a B4? This angle B4 is between the tangent and this chord, isn't it? And this chord is subtending what? D2. Is it clear? So B4, angle B4 is equal to angle D2. Where do I reach at the end? At the end, I have to get angle A. So I have to equate angles like that. At the end, I have to reach angle A. So where am I now? I am at D2. B4 and D2, they are equal. What is the reason? Tan chord theorem. Tan chord theorem. Is it okay? Do you understand up to here? Okay. Now I am at D2. I started from B1. Now I am at D2. D2 and A, are they equal? D2 and A, isn't it exterior angle of cyclic chord? Isn't it? Exterior angle of cyclic chord. D2 is this cyclic chord. See this side extended. This exterior angle is equal to opposite interior. What is the opposite interior? A, and that we are looking for, isn't it? So D2 is equal to angle A. So we are done. What is the reason? Opposite exterior angle of cyclic chord. Exterior angle of cyclic chord. Clear? Therefore, we can say B1 is equal to angle A. So these two angles are equal. We are done. Therefore, we can say what? The side EA is equal to EB. What is the reason? Sides opposite equal angles. Isn't it? Sides opposite equal angles. Sides opposite equal angles. So we are done this question. We proved that EA and EB, they are equal. You can go to the next question. Okay, now coming to question number 10.2.2. The length ED, EA and EC in this order form a geometric sequence. You have to prove that ED, EA and EC are forming in that order forming a geometry sequence. See, geometry sequence, you know that geometry sequence is part of number pattern, and this one, the one that we are in, is Euclidean geometry, isn't it? But it can come like that. So you just follow the rules. In that order means this is our T1, then T2, and this is T3. So 10.2.2. 10.2.2. You know that the geometric sequence, it has common ratio, that is T2 over T1 is equal to T3 over T2, isn't it? Okay, so you have to substitute, that is EA over ED is equal to EC over EA. You just prove this. If you can prove like this, then we are done, which means it is the ratios are same. What is that ratio? Here in this context, they are the common ratio of geometry sequence. Or you can even cross multiply. Instead of this one, you can prove like this: EA square is equal to ED times EC. Any one of this, either this one or this one, if you can prove, then we are done. All right, now how do you show that? Since they are talking about the sides, we need to look for two triangles and show that they are similar. And then after that, we can get the sides and just do it. Maybe you will get something like this. Okay, so which two triangles you are going to choose? Since they talk about ED, ED is this side. Then EA is this side, isn't it? Okay. Then EC is from here. See this one, EC is this one, okay? Yeah, but we already proved that EA is equal to EB, so this side, isn't it? So EA and EB, they are same. So I'm just checking, I'm just taking like this, the triangle EDB, this EDB and ECB. I'm just taking like that, EDB and ECB. I'm just triangle EDB and triangle ECB. If I can prove that those two triangles are similar, then maybe I will get this, I can arrive at that result. Okay, let's see. E is common, right? Angle E is common in both. Common. So one angle is there. Then angle B2 of the smaller triangle is equal to C tan chord theorem. Is it clear? In the bigger triangle, that is B2 is equal to angle C. So tan chord theorem. Then which pair is left there? D1, isn't it? D1 is equal to D1 of the smaller triangle and B2 plus B3 of the bigger triangle. So D1 is equal to B2 plus B3 plus B3. That is third angle. Is it clear now? Okay, so this order is very important. So you have to name it triangle EBD, isn't it? EBD is equal to, I mean not equal, it is similar to triangle ECB. ECB. We prove that one by angle. Okay, so let me try the sides, that is EB over EC is equal to BD over CB is equal to ED over EB, isn't it? Okay, so which ratios you have to consider, because it has ED, so this ratio must be considered. Then it has EC, that is this ratio must be considered, isn't it? So just take those two ratio, that is EB over EC is equal to ED over EB. Then cross multiply, you will get EB square is equal to EC times ED. But EB and EA, they are same. Okay, so we are done. That is EA square is equal to EC times ED. The reason is EB is equal to EA. Isn't it to be proved this ratio? Yes. EA square is equal to EC times ED, which means ED, EA and EC, they are terms of geometric pattern. Is it clear? So this one is a variety question. So guys, try to understand. Thank you.